Hi everyone, thank you for joining. Today my name is Manam and today we're going to be looking at kinetic energy. So we have a few learning objectives and that's to define what kinetic energy actually is. We have to understand the factors that affect kinetic and to recall that kinetic energy is equal to half multiplied by mass in kilograms multiplied by v squared second. So let's get right into it. Okay, so first we want to understand what kinetic energy actually is. Well, kinetic energy is nothing but the energy associated with moving objects. So I have here a couple of examples. I have a snooker and we have arrows coming out of a bow, right? Right. So any sort of moving object with a mass, you should think, oh, this object has kinetic energy. Now let's have a closer look at the actual kinetic energy equation itself. Now, the kinetic energy equation goes for ng, but usually I use a little subscript to show that it's specifically kinetic energy because E for ng represents a huge amount of things, so we just want to keep it specific. So EKE, ng kinetic half, which is just a multiplied by the mass of an object multiplied by the velocity squared of an object. Now, a lot of people get confused and sort of square everything. It's not square everything. It's only velocity squared. Now let's have a look at some of these quantities. Now, we have ng, which is always in joule, no matter what form of ng is. A half, just an integer, no units. The SI standard kilograms. But anytime you see in a question grams, I have to convert it into kilograms, and our velocity is always in second. Okay, so that's all of our different quantity kinetic energy equation. Now let's have a look at how kinetic energy varies with each of these. Well, if we take, let's do it in this over here. If we have, but now say we were looking at the same mass of, so cancel mass and a half out because they're just going to be the same constantly. Now you can see is directly velocity squared. So if we double our velocity, we don't get twice the ng, we get 4 times the ng. It's always a square, okay? So that's how we can see the relationship between ng and velocity. Now let's have a look at and mass half okay. Now we assume velocities. Let's get rid of that. Let's get rid of that. Now we can see that directly proportional to mass. So if we were to double the mass of an object, double the kinetic energy. Now there is a trade-off here. We can also have very small objects such as bullets, huge amounts of kinetic energy. Why? Because they travel extremely fast. Because of the square, velocity is often a larger factor in determining kinetic energy of an object. So you need to understand that these two things affect kinetic energy, mass and velocity. But don't always think that, oh, if it's a smaller object, a lighter object with a lower mass, it should have a lower kinetic energy. No, you have to factor in velocity. A golf ball and a tennis ball, however, if they were traveling at the same velocity, we can say that obviously the tennis ball is going to have a higher kinetic energy because it's heavier. But if you were comparing, say, a bowling ball and a bullet would have way more kinetic energy than the bowling ball simply because it's going more than triple, quadruple the speed that a bowling ball can possibly be thrown at. So now you understand what kinetic energy is, factors that affect kinetic energy, and the kinetic energy equation. Okay, so now let's have a look at a worked example. So as always, we're going to highlight all of our keywords. So a bullet of mass 25 grams, straight away that's a keyword there, is traveling at 560 meters per second. Calculate the kinetic energy associated with the bullet. Okay, so first of all, let's write down my kinetic energy equation. Ke m squared. Okay, now let's write down all of our units. So energy in joule, half is just an integer, mass is kilograms, velocity squared is a second. Okay, so we have our velocity is 560 second, but we also need our mass. But our mass is given in grams, so we need to convert that into kilograms before we use it. Okay, so we can just do that in the actual formula line itself. So let's just substitute all our values in. Half times. Now we need to convert our mass into kilograms. There are 1,000 grams in a kilogram, so we just 5 over 1,000 multiplied by 560 squared, because remember it's velocity squared. That gives us 3,920 joules. Okay, so that's our answer right there, and that would be